Okay, so we're going to go over a few things on this list. So what's on the list for this section? It's called one variable, meaning only one letter, one unknown, x, in all these cases. We really could call it anything. One variable, inequalities. Inequalities is not equations. Equations have equal signs. Inequalities uses these symbols that were introduced to you in like second grade, right? Less thans, greater thans, or less than or equal to, less than or equal to. Here we have a greater than symbol, right? If I read this backwards, I can say 91 is greater than or equal to 3x plus 14, okay? So in this section, we have a few things we want to be able to address. So this is all things you should be able to do when all is said and done. One, can you solve one variable inequalities? Solving means getting what alone? X, right. Graphing one variable inequalities. Where are you graphing these things? Are you graphing them on an XY plane? On a number line. You should not be drawing an X and Y axis. Really, you're only drawing the X axis. If you think about it, if you only have one letter, you won't have two axes. It makes no sense to have two axes. Open versus closed. Well, this we could even address right now. Do you see this example has a less than or equal to symbol? The equal to portion of it means that when you put your circle on your number line, do you color it in or do you leave it open? When you have that equal to portion, yes, you color it in. If it's colored in, we say that that is closed. So I'm adding notes. For example, one right underneath here, it's called closed. And you would use a bracket on a case like this. So I'm going to use the word bracket with a square bracket on either side of it as a bit of a hint. Now, it's not just this symbol, the less than or equal to, but it also works for greater than or equal to, right? Because when we do this other thing down here, interval notation, we need to know brackets. So that was in the video. That was extra credit on the last test if you remembered how to do it. But now I really want to reiterate what that is so that we, real deal, know how to do this, okay? So this closed point is a colored in dot, means our inequality had one of these symbols, and then it'll also equate to us using a bracket. That's one thing. Now, the next thing from there is continuation. If it's not less than or equal to or greater than or equal to, what could it be? What, just less than or just? Right, it could be just less than or just greater than, right? In that case, do you color your circle in? No. If it's not closed, then what do you call it? You call it open, exactly, it's open. And then when we do interval notation, for anyone who remembers, because I know a couple of you got that extra credit, right? What, if we're not using a bracket, which is squared off like this, what are we using? Parentheses. If you can't see too well, there's two more open seats here, oh, actually three, right? 1, 2, 3. So if you're in the back and you can't see well, feel free to move up. There's a chair there if you want to put that stuff down. You can sit on the rug for all I care if you have something to write on, okay? So we're going to use parentheses for these. Parentheses, okay? So we'll deal with that in a second. Actually, I think, yes, one's plural, one's singular. I messed that up. So I'm going to leave that in my notes section over here. Now, I don't want to say, a lot of people sort of memorize that less than means left. But remember, you have to read each example how it's presented to you. And it's a case-by-case basis. The example I even gave was like, my age is larger than Rhea's age. But we could read it the other way. Rhea's age is lower than or less than or smaller than my age. So like, it depends how you read something. The X ended up on the other side kind of thing? Or?
Yeah, and it's like 10 is less than 35. And like, also like 10 is greater than something else. So that was confusing.
Yeah, so that's going to be like a compound inequality, sort of like this example or that one. Or here we have the word or. Sometimes you have the word and. So you put it all on one number line, okay? And you really want to find this overlap. So it reminds me of like a Venn diagram. So if I said, you know, we need to find a student. Now, say all the students in the high school could be split up, right? We have, you know, male students and female students. But then we also have other separate groups of 9th graders, 10th graders, 11th graders, and 12th graders. So what if I was like, oh, I need to find a student who is a female, and then we have driving and non-driving. I need to find someone who is female, who drives, who is in 11th grade for this potential babysitting job. So it's like you want to find someone that satisfies these three categories for some reason, right? These are the criteria you need to match up, and you find one person that matches those things. Maybe there's more than one. Maybe there's 20 people who meet that. You know, 20 girls who drive in the junior class that, what else did I say? Girls drive, junior class, that's everything, right? Yeah, so there might be more than one answer. So when you have these compound inequalities, and we'll talk about that more in a second, you need something that's like, oh, less than 35 and greater than 10. Sometimes it'll be the word or, it could be like greater than 10 or less than 2. You know, you'll see each case by case. And or are two different things. So it's like, if I want something to be this and that, it's like simultaneously, I want, I'm getting ice cream, right? I got a cup of soft serve ice cream. I want sprinkles and chocolate syrup. Versus, ooh, I get a topping, I would like sprinkles or chocolate syrup. So I could have sprinkles, I'll be happy. I could have chocolate syrup, I'll be happy. But I'm really supposed to pick one or the other, so that's what I want to pick. But if it's an and, it's like I want both of those things at the same time. Okay? Got it? You guys following the difference between and versus or? Okay, so here I want to get x alone. So Sam, what can I do to both sides to get x alone? Add 10 to start it off. That's the addition property of equality. We add 10. You treat your inequality like an equal sign. If I add 10 to both sides, 3x equals or is less than or equal to, don't change the sign. Be careful. A lot of times you guys are losing the equal part. Like if it says less than or equal, you're accidentally writing less than for the next step. Jeremiah Ricks, what's 35 plus 10? Yep, 45. Next step, what do I do to get x alone, Ilsa? And what do we get? 15, good. So right here, I'm really done with one part of this. This solution is called the inequality solution, okay? If I say solve the inequality, we're done. This is the inequality solution, finished. Now, these problems, I'm gonna have us do 3 things for each of them. 1, we're gonna do the inequality. 2, so solving one variable inequalities, that's pink, finished. 2, the next thing we're going to do is we're going to graph it on a number line. So if I graph this on a number line, first and foremost, please save yourself some time. Don't draw me 1,000 tick marks. Guess how many tick marks I really need? 1. I need 1. Just label me the number that's in the problem. If there's 2 numbers in the problem, yeah, give me 2. So graphing the inequality, so that'll be blue, okay? I'm going to squeeze it down here, I guess. Yeah, right here underneath. Here's my number line, an arrow on each side, not colored in. Don't color them in unless you shade that way. Now, some of you have pretty weak shading. You're just drawing this like light line on top of it that like I have to like get a magnifying glass to tell what's going on. I'm going to put 1 tick mark where I have some space. So right here I have some room. What am I labeling this tick mark with? 15, right? Is this going to be open or closed? Closed. So right here, don't make it difficult for me to tell what's going on. Color this guy in real good. Boom. No mystery, right? Clearly colored in. Now, read it again. X is less than or equal to 15. Josh, can you give me an example of a number that's less than or equal to 15? Any number that would qualify as being either less than or equal to 15. 10. Done. 10 is less than or equal to 15. Is 10 on this side or this side? Is it on the left or on the right? It's on the left. So 10 would be over here, and that is less than 15. So which way am I shading? To the left. Okay? So that, again, there's no mystery. When you get to your arrow, really color this in really, really well. Okay? So this is colored in. I'm not unsure about which way the answer is shaded. So is my number line done? Yes, I graphed my one variable inequality. I took notes over here on open versus closed parentheses versus bracket. Okay, now we don't need to flip in this example, so don't worry. It's not absolute value, but I have one other thing here called when do we flip an inequality? We don't need to for this example. When do we flip our inequality symbols, Josh? Right, when we divide by a negative. I don't care if the numerator is negative. A lot of you guys like asked me like 10 times the other day to be sure. I get it's a little confusing. When you divide both sides by a negative number, like this 3 that we divided by on this step, if it were negative 3, that's when the sign flips. Only when you divide or multiply, really, both sides by a negative number. And we'll see one example like that in a minute. Can you tell which example is going to make us do that? There's 2 on the screen right now. 5 is one of them. We're definitely going to have to divide by a negative in number 5. And 3, good. Here and here. So we'll deal with flipping the negative, we're flipping the inequality in those. So interval notation, all right, over here I'm going to use green to do that. Now, if any of you guys, I have a few colored pens, I have a few highlighters. If any of you guys want, you can borrow from me. I have a few colored pens in this jar. I think there's some other colored pens in there with the pencils, or is it just pencils? Just regular? Okay. So there's a couple, if you want, colored pens. These are my borrow pens. And then my highlighters are over here if you want to color coordinate yourselves. Maybe you want to do it after the fact. My highlighters that look like this, like these little guys, are erasable highlighters. So, yeah, they're pretty nice. Yeah. So if you want, you can use them. But if you're using it, remember, over like regular pen and pencil, it might get a little messy, but it at least erases. So I do have them. Some of them are a little dry. I have to throw them out because I use them a lot. But if you want one to borrow for today, just don't steal my tools over here, okay? So they'll be sitting here on the side. And like I said, the pens are also here. If you want some color coordinating, I'll bring some colored pencils next time or something, okay? All right, so in green. Interval notation is a different way of writing our answer. And interval notation looks a little bit like an ordered pair, okay? So I'm going to put a little bit of a note. All right, I'm going to write interval. When you hear the word interval, what do you think of? Interval, that's a little hard to read. I'm going to use a darker green. Not really a number, interval. What else do we think of? Anybody have a better way to explain what an interval is? An interval. Like from this interval of time, you should be running the 50-yard dash. Or from this interval of time, from 11:47 to 12:39, you should be in your math class. So the interval of time, do you see that I gave like a starting point and a finishing point, right? So it's sort of like telling you like this window from start to finish that you're looking for your solution, right? So my interval of my shaded region of my solution, describing all the x values that will satisfy this, where I want to go from left to right. What's the smallest value that satisfies this equation? Where does this arrow shade until? Not until 1. What kind of infinity if it's all the way to the left? Yes. All right, you with me, everyone? So negative infinity is the smallest thing, all the way down on the left. So can you ever reach negative infinity? If you keep going forever with numbers, will you ever get there? No. So when we can't get somewhere, that's an open point. Like when you say it's less than 5, is 5 included in the answer? No, you don't get to 5, you don't reach 5. If it's less than 5, you're at like 4.999999999 forever, right? You never hit it. So anytime you can't get to a number, we use parentheses. So it looks like an ordered pair. So it's like saying, all right, from negative infinity, that's where we start on the left.
How come you wrote close next to the?
Because that's for 15. Close is the number we get to. So when it's less than or equal to, like we're always going to, every number we could say is greater than negative infinity. Can you think of a number less than negative infinity? No. So it's like, that's like that unachievable number that I can never ever get to is negative infinity. Everything's bigger than negative infinity. And everything's smaller than what? If everything's bigger than negative infinity, everything's smaller than positive infinity, right? So now we're going from left to right. So what's the biggest value I can go up until? 15. Is 15 included? Yes, it's colored in. So this gets a bracket. So the answer to my interval notation, which actually gets easier to read than this thing that I have in pink, is from negative infinity until 15, and 15's included. That's your answer, done. So 3 things that we accomplished in this problem. 1, solved an inequality. 2, graphed it on a number line. And 3, wrote the answer using interval notation. So interval notation, as I do more examples, it's going to become clearer and clearer. And whatever notes we want to add, if there's something we talk about, I'm going to add it for the notes. If I don't need the notes, I might write into that space, but I just blocked off a little area for that.
Is there an absolute value one?
Yeah, that's going to be down on the bottom of the page. We'll get there. Okay, so I'm going to keep the same colors going on for these. So again, I'm on the pink. I'm solving the inequality. So anyone want to get there participating in now? Some tell me what to do first, Jay? Good, we'll subtract 5. We're trying to get x alone on both sides. So 7x is less than how much? 4. Then, sorry, it's a little squash looking. That's 7x, and that's a less than sign. We got to keep going to get x alone. What do we do now? Jeremiah? Divide by? Yes, we're going to divide by 7. Hurry up. Yes, we're going to divide by 7. X is less than 4/7. Now, don't worry about making a decimal. Don't do long division. Don't go crazy. This is beautiful. We love this the way it is. Beautiful. Question, Nicole, or no? Okay. Question, go ahead, Sam. Fill out a pass right here, and I'll sign it. All right, so that is good the way it is. Here's one. I just use this. Okay, yeah. Use a pen then. Okay, pen. All right, so from here, next thing, my number line in blue. Now, do I need more than 1 tick mark for this example? Is there more than 1 number really involved? No. So all I really care about is 4/7. Out of curiosity, what is 4/7 between which 2 numbers? 4/7 is bigger than 0, but less than 1. Good. Okay, good. So you should know it's between 0 and 1. Is it closer to 0 or is it closer to 1? Not by my drawing, but in reality. Is it closer to 0 or closer to 1? Is it more than halfway? Yes, no. Huh? What's
wait, I'm dumb.
You're not dumb.
It's closer to
It is closer to 1. What's right in the middle? How much over 7? It's kind of weird to say. 3.5 over 7, because that's a half. You guys understand what she's saying then? So 3.5, not drawn to scale. 3.5 over 7 is halfway. Everyone listening over there? All right. Avery got it? Can you nudge him? All right, we're good? You got it? Right? So we're here. Now, 4/7, is that going to be an open or closed circle, Avery, at 4/7 for number 2? It's open. X is less than 4/7. Which way do I shade, Aaliyah? I want to shade where the numbers are less than 4/7. Smaller than 4/7. Towards the 0. Good. So we're going to shade to the left towards the 0. This is where the numbers are less than 4/7. So when your inequalities are written where X is first, you could pretty much shade the way the arrow is pointing, but like, again, that's not always the case. Now, similar to this example, we're going to go from left to right. What's the leftmost thing that's part of my solution? The leftmost thing that's part of my solution, Soroya. What is the smallest number in my solution set that's shaded over here? It's similar to this example. So in green, I'm going to write my interval notation. What is this shading towards forever and ever and ever? What kind? Yes, negative infinity. Do we ever reach negative infinity? No. So do I use a parenthesis or a bracket, Sahai? We use a parenthesis and then comma. So the way we read it, like I said, it looks like an ordered pair, but it's not. From negative infinity until, what number do I keep shading until, August? Well, it does matter for this example. Which number is like our boundary? What? No, what number tells us where to stop shading? There's no 7. This is 0, 4 sevenths, and 1. 4 sevenths. Now, is 4 sevenths included or not included? If it's less than. Gabby, is 4 sevenths included or not included? Like, does it count as a solution? It's not included. So if we don't include it, is it open or closed? Is it a bracket or a parenthesis? What shape should I put with this 4 sevenths? Gabby, you think you can know? Good, it's a parenthesis. Done. So do you see the parenthesis went with this open circle. The bracket went with this, the closed circle. A colored in arrow to the left goes with negative infinity. What do you think a colored in arrow on the right goes with? Yes. So I'm going to put some more notes down here. If my number line colors all the way that way, right? I don't know if this is open or closed. That's negative infinity, and it's a parenthesis. If my number line, I'm drawing it separate over here. If my number line is shaded all the way this way, I'm not talking about what this is or not, okay? Then what's this pointing at? If that one's negative infinity, what's this one? Positive infinity, which will also get a parenthesis because we can never reach those values. Okay, I don't know what's happening in the middle. I'm going to draw a little zigzag. So make sure we know that that's what we're dealing with. If it's an open circle, you'll have a parenthesis with that number. If it's a closed circle, you'll have a bracket. It all depends from left to right, one way or another, okay? Next example, same thing. We want to get x alone. Got to get x alone for this one. JR, how can I start example 3, the first step to getting x alone? Take away 13 from both sides. You keep it balanced. So minus 13, minus 13. Now, when you're doing stuff like this that requires borrowing, I think it's a good idea. Here's negative 2x. Oh, I wasn't supposed to use green for this. It's supposed to be pink, right? Oh, well. So I think it's a good idea when you're doing a problem like this one to take away 10, then take away 3. So it's 51, take away 10. 51 minus 10. 41. Okay, so I have negative 2x. Negative 2x is less than or equal to 41, but now I got to take away 3 more. Take away 3 more from 41. 3 more. So if you took away 1, you're at 40. 2 more, you're at 38. So less than or equal to 38. So go slow. So see what I did? I took away 10, then I took away 3, right? 10 and then 3. Now, next step to getting x alone, what do we do? Divide by negative 2. Good. Dividing both sides by negative 2. Now, what did we say? We have to remember if you multiply or divide both sides by a negative. Yes. So I'm going to write x is what, Emerson? I'm dividing both sides by a negative number. What am I supposed to do with my inequality when I divide both sides or multiply both sides by a negative number? Flip, right? So this becomes what? X is, can you read off what it would be? Greater than or equal to. Now what's half of 30? 15. What's half of 8? 4. So what's half of 38? 19. What's a positive divided by a negative? Negative. So it's negative 19. Notes on example 3. What should I write down? When you multiply or divide, I like to write the word multiply and not just put a dot. I feel like people get confused. Divide both sides by a negative number, flip the, and I don't want to just say sign because I don't want you to think I mean positive or negative. By sign, I mean what kind of sign? The inequality sign. Inequality sign, right? I'm going to go down, S-I-G-N, okay? Flip the inequality sign. Got that rule? Okay, we all got it? Now, we flip the sign. What's the next step?
The number line.
The number line, good. So if I draw out my number line, what numbers should go on this number line, JR? Really all I care about is negative 19. Now, do my numbers get smaller as I go left, or do they get smaller as I go to the right? Always smaller to the left. I want to know when the x numbers are greater than or equal greater than or equal to negative 19. So which way am I shading? And is my circle open or closed? Who can tell me? Who can tell me? Nafia, open or closed? It's closed because it's equal to. Am I shading to the right or to the left? Yes, this way. Good. Shade it to the right, okay? Interval notation for this one in green. Interval notation for this one in green. How about Nicole? You alive back there? Okay. What would this one be from left to right? Parenthesis for where? Are we talking about this spot? What's the first thing included in my answer? What number or value? Am I starting at negative infinity, Nicole? Is that colored in? The colored in is this, right? Negative 19. Is it included? So do you see where I'm pointing here on the left? Because I'm going from left to right. So in these cases, the leftmost thing colored in was the arrow. But is my arrow on the left colored in this example? Do you see it's different? These two are similar. This one is different. So now I'm starting at this closed point, Nicole. So is negative 19 included or not included? So do I put a parenthesis or a bracket? Yes. So you're saying from negative 19, comma, it means basically until when? I'll put some notes here to help us. Yes, I heard it, until infinity. Good. So until infinity. Do you see that one was like different than the first two guys? Yes? Yeah, well, we'll get there with practice. So it's just going from left to right. That's all. So it's like, oh, if everyone else's name, so you met a whole bunch of friends, right? And they're like, oh, this is Thomas Smith, and this is Thomas Jones, and this is Thomas whatever. And then someone was like, oh, and this is Dad Thomas. And they're like, wait, what? Thomas should be your first name. That's everyone else's first name. No, it doesn't matter. It's my last name. So like these all started to the left at negative infinity, and they went until a number. Whereas this one is starting at a number and going until infinity. That's all. We're just describing what's colored, okay? And what's shaded, those are the solutions. Now here, next we have the compound inequalities. So Josh, what do you think we have to do in our effort to get X alone for example 4? From all three places, here, here, and here. Now, do you guys all see that like this is just less than and this is less than or equal to, that they don't need to match? Yes? We all see, right? So Ilsa, what's 25 take away 14? 11. August, what's left in the middle? 3x. What's 91 take away 14, Avery? 91 take away 10, take away 4 more. 91 minus 14. 77, good. Then I'm going to divide by what number, Jeremiah Ricks? I want to get x alone, so what do I have to divide everything by? I want to get x alone now, by 3, good. Now do 11 and 77 divide by 3 nicely? No, so guess what we do? Nothing, we leave it, okay? Ovan, what number is smaller, 11 thirds or 77 thirds? 11 thirds. So what will I put on my number line for this one? Ovan. Right, we're going to put 11 thirds and we're going to put 77 thirds. Both numbers, okay? 11 thirds and 77 thirds. Now I have two nice big noticeable circles. No questions. Do not give me a teeny weeny dot. Got it? No teeny weeny dots. You're all covering this? Raya, what's that going to mean for your grade? It should have been there. Is this circle colored in? Yes or no? Jay, 11 thirds. Is that colored in? Yes or no? No, it's less than, not colored in. Yes, it's closed, okay? They don't need to match. Don't make them match just because you feel like it. Now, this is what people are messing up. Ready? Reading one at a time. X has to be less than or equal to 77 thirds. So which way is less than 77 thirds? Jahari? After you answer these two questions. Which way is less than or equal to 77 thirds? Is it to the left or to the right? Left. So far we're this way. Now, I also need X to be what? Read this from X to the 11 thirds. How do I read this, Jahari? Right, X has to be greater than 11 thirds. So here's 11 thirds. Which way is greater than 11 thirds? To the right. So I'm going to only shade in the middle. Only shade in the middle. Do not let me see this all colored in and this all colored in. Really, yes, it's like this way, and we're finding the overlap. So it's like a Venn diagram, okay? It's like a Venn diagram, but your final answer is just that overlap right there. Now, for the interval notation, is infinity going to be in this answer? No, neither arrow is colored in. So Armand, from left to right, what is the first thing that marks off where we start finding our shaded region? Is it included or not included? So what shape goes with it? What symbol? A parenthesis or a bracket? Good. Then what else do I keep writing? Comma. Perfect. And then? Now it's a bracket. Done. No infinities in this example. Why? Because you're not coloring forever in any direction. So that's done. Here, we're going to move quicker and finish up these next few. Here, if I want to get this alone, anybody yell out for me and then I won't call on you. What do I subtract from all three places? 10. Okay. If I only hear the same people over and over, I'm going to start calling on you guys again. 25 take away 10 is? 15 is less than? Negative 7x is less than? 81. Divide everything by? Negative 7 in an attempt to get x alone in the middle. We divided by a negative. X is alone. What does this become? Greater than. I'm going to move the negative up top and just do 81 over 7. I'm going to flip that also, right? So x is less than negative 15 over 7. Good. All right. I have no idea. I don't think it's mine, I hope. No, it's not. Guys, you should have your sounds off. All right, here. I'm drawing a number line. Anybody tell me what number goes on my number line? What numbers? And? Who's smaller? Negative 81/7, I heard it. Okay, this is smaller. What's smaller, negative 81 or negative 15? Right, so negative 81, as long as they have a common denominator, you can compare the tops. So there's negative 81 over 7, and this is negative 15 over 7, okay? X is greater than negative 81 over 7. So I'm bigger than this number. Does this circle get colored in? Do I shade to the left or to the right of it? X is greater than. That would be to the right. And then make sure, do you shade to the left of this one so you can shade in the middle? X is less than negative 15 over 7. Yeah, so there's the middle. It's probably always going to be the middle or the two outsides. You just got to really, really confirm one of them, and you should be good. Now this one, what is the interval notation for this? Interval notation. Similar to this one, parenthesis, negative. Go ahead, be brave. 81 over 7, comma. And is that included? No. No, it's not colored in. Done. That's it. Next. Next is almost the exact same thing, except it's just, instead of it being conjoined in one inequality, which is, when they're like this, these are really and statements. It's this thing and this thing at the same time. Maybe they had you do it overlapping just so you learned separately and then you found where they overlapped and what they had in common. One way you also may have seen graphs for these to kind of show a little bit. I'm just going to draw another side example here. Like, let's say I had two, you guys remember like primary and secondary colors?
Primary yellow, green. No, yellow, red, blue.
Yeah. So I'm going to use, just because I don't have every color over here, just humor me. Pretend pink and yellow make orange for a second. Close enough? Okay. So it's like, oh, if I had these two number lines, if I had something like x is less than 10 and x is greater than 4. Here's a number line, right? Here's 4 and 10, but I'm going to draw another one right underneath it and a third one underneath that. All the same numbers. Those are 4 and 10, okay? If I just did x is less than 10 with orange, here's 10, here's less than, that way, correct? You guys agree with me? Then if I did, after that, x is greater than, oh, I shouldn't have done orange, right? I should have done pink, primary color. So pretend it's pink the whole time. Okay, then x is greater than 4. Here's 4, greater than 4, I shade that way, right? Where are they both colored? If I went down, like, if all this melted down onto this axis, the middle, right? Here, orange exists because yellow and orange are both yellow and pink are both happening. The middle is where they're both happening. If they melted, if they were like crayons when you were a kid and you left them out in the sun, crayons you left out in the sun, right? Where would it be an overlap of melt? Right there in the middle. Everyone see it? So instead of doing two separate ones like you maybe did in geometry, I just do one number line, all right? Oh my gosh, right.
That's my fault.
Yeah, you left your sound on, Jeremiah. Okay? You left your sound on. It's been going off like crazy.
I heard y'all.
1.5 minutes. All right, next example with the or. This is only a few steps. Participate, and I don't want to just hear Rhea. Okay, what do I do first for this one? Divide by 2. Good. X is greater than 4. Nice. What do I do for this one? Subtract 4. Subtract 4. What's 1 take away 4? Negative 3. So I can be this or that. I'm going to write the word or in the middle anyway. Carry it with me. Now, number line. What numbers am I putting on the number line? Think before you write. This will be which one? Good. Negative 3. This will be 4. Open circle, open circle. Color any of them in? No. X is greater than 4. Which way do I shade from here? Yes, to the right. Arrows colored in. So who's going to be involved in my interval notation?
Oh, you meant like the number.
Well, Rhea, because she participates, but who, I mean infinity. Okay? Ilsa, -3. X is less than -3. Which way do I shade? Less than -3. Is -4, -5, -3, negative that way? Or this way? Which way? I don't, you tell me. What did you say the first time? I don't know. Yeah, it is to the left. Sorry, I couldn't hear you. That's why. If you answered, I couldn't hear because I was babbling. Okay, so we're this way. Emerson, when the arrows are colored in, who's involved? Infinities. Which infinity is this, Emerson? Negative infinity. So I'm going to start there. Here's a different case. Negative, oh, that's too bright. Negative infinity until -3. I use what symbols on both of these? What symbols am I using? Ovan? Parentheses. Now, do you see that this is an extra batch of answers separated from the last batch? Josh, do you remember what symbol we're supposed to put in the middle? Well, to connect the two answers. Does anybody remember there's an extra symbol? Yeah, it's a U. And the U really stood for kind of like what word? Union, unite them. Sure, it's the union symbol. It really should be next to I'm just squeezing over here. Then I start up again at 4, comma, and we go until? Good, infinity. So when you have 2 patches of answers, or 3 or 4 or 5, you're going to unite them together with this symbol called the union symbol, okay? So there's my answer using interval notation. So maybe I add notes down here, right? Maybe I write U, union symbol. It's not a regular U that has like a little tail on it. It just unites 2 different sets, okay? Here in both of these, arrows are not colored. Arrows are not shaded. So what does that tell me? If the arrows are not shaded, no negative infinity or infinity in the, what's the name of the green answer? What is the green stuff called? What kind of notation? Good. Interval notation. Okay? Now, if I'm writing it as notes and I do this all day, every day, I guess you should also be having this as notes, so you're not asking me what the symbol means in, a few minutes, right? Arrows are not shaded, so no negative infinity or infinity in the interval notation. And interval notation, again, I'm going to color coordinate my notes, is green, interval notation. Arrows are not shaded. What am I talking about? The shading is the blue part, right, on the number line. So they're not shaded, so there's no infinities. Now, what I'm going to have you guys do is you're going to finish this one only for homework. No absolute values because we need some work on these together. You're going to do that little cutie pie for homework, and I'm going to make up one more down here in the little section on the bottom of the page. So down here, you're going to copy this one. Ready? Let's do 3x minus 7, and we're going to do these symbols. Let's do negative 35, and actually, let's change that to, oh, that's fine. Make that a 2x instead of a 3, okay? I'm going to make the numbers a little easier. 2x, negative 35, and let's make this 21. Okay, that's a 2. I know it's a little ugly. I apologize. So this is homework. You're going to do all 3 things. This is homework. We're going to go over these 2 examples first thing tomorrow, and then in class, I'm going to give you a little baby quiz on just inequalities. We need a little bit more work, but you have to do all 3 steps. The pink step is solving the what part? Just the, it starts with an I. Inequality. The blue is doing what? Graphing on a number line. And the green is interval notation. So all 3 parts. So I'm going to save this video. I'm going to post it to the classroom right now. Okay, it takes a little while. And that'll be a little quiz of first grade of the second marking period is going to be going over interval notation. So again, one more time. Pink is solving the what? Pink is solving the inequality. Blue is graphing on a number line. Green is finding the, you have to do all 3 parts. When do you flip your inequality? Or multiply by a negative, right? Once you get x alone. If you have 2 numbers on a number line, do you see these 3 examples? You're either shading in the middle or on the outsides, okay? Oh, the homework one again is, it'll be on Google Classroom in a few minutes. It just takes a little while to upload, okay? Have a nice day.